Hey guys, today we're going to talk about binomial expansion. So I know this feels a little bit out of left field, but it's really not when it comes to sequences and series, because really it follows a certain type of pattern, which is a sequence. So, first of all, what is binomial expansion? So, a binomial is when we have two terms added together, so a plus b, x plus 4, y plus 7, something like that, to a power. So, when we write that all out as a polynomial, that's binomial expansion. So, when we multiply that entire thing out. So one way to expand a binomial is to use Pascal's triangle. So the first thing I want to mention is Pascal. So one of the things that happens quite a bit in history, especially being in the United States, is that we really get the westernized side of the story. So when we talk about Pascal's triangle, that's fine. That's what you're going to hear about when you go through college and things like that. But there's also this mathematician named Yang Hui, and about oh, 300 years before Pascal was using Pascal's triangle. And he had actually gotten the idea from another Chinese mathematician. So a lot of times math ideas you're going to see named after a European having discovered it, when really, no, they didn't discover it, and these ideas were either discovered simultaneously or even earlier in Asia and India and places like that. So, throwing it out there. So, what the heck is Pascal's triangle? So, we're going to start with a 1 right up on top. And what you might notice is all the way down here, we have 1s all the way down, right? Cool. Now, let's look. What do 1 and 1 and 2 have in common? What do 1 and 2 and 3? 1 and 2 and 3. What you might notice is that the sum of the two numbers above it gives you this number right here. The sum of 1 and 2 gives you 3. The sum of 2 and 1 gives you 3. The sum of 1 and 3 gives you 4. The sum of 3 and 3 gives you 6. The sum of 3 and 1 gives you 4. So on and so forth. So what I'd like you to do right now is copy this and then fill in the rest of Pascal's triangle. Okay, so hopefully you paused me and you did that. I'm going to go ahead and fill this in. So I add together 1 and 5 and get 6. I add together 5 and 10 and get 15. I add together 10 and 10 and get 20. 10 and 5 and get 15. 1 and 5 and get 6. And if you notice, all the way down, those are always 1s. Let's do the next row. 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 5 plus 6 is 21. 6 plus 1 is 7, and then a 1. You might notice that if we were to split this guy right down the middle, it's symmetric on both sides. So that's going to be helpful. Let's fill in this last guy. 8. 70, 56, 28, 8, and 1. Good deal. Okay, so this part is going to be a little bit weird. It's how we define which row is which. So, this guy is actually our first row. All right? This guy right here, second. This one right here, third. So it really corresponds to the second term, or the second to last term is your row number. So what about this guy? What is he supposed to be? He is the 0th row. Yes, it's 0th. That's how they define it, with the TH on there and everything. It's 0th. I'm not just pulling something out of my butt to be cute. It's real. Okay, so then this is 4th, 5th, 6th, 7th, 8th row. This is going to keep on going to infinity. You can make the triangle as big as you would like. You can see that we're going up by 1 here every time. You can see right here that these are, I'm going to leave it. There's a lot of fun stuff with Pascal's triangle that could be really fun to look into. Anyway, it's going to keep on going. So, why do we care about Pascal's triangle, and what the heck does it have to do with expanding a binomial? Well, whatever this power is matches up to the row. So the power is going to define which line we're on, and then that line of the Pascal's triangle is going to tell us the coefficients for each of those terms. So in the first line, the 0th line, that would mean that it's to the 0 power, right? So anything to the 0 power is 1, so that makes sense why that first one is called the 0th row. And then to the first power, well, a plus b to the first is just a plus b, so each of the coefficients are 1. Then when we start to square things, we would take a plus b times a plus b. When we would multiply all that out and then combine like terms, we would end up with 1a squared plus 2ab plus b squared, or 1b squared. So if you notice, the coefficients for each of these match up with the coefficients, or match up with the row in Pascal's triangle. So if we were to look at a plus b to the 4th, then I would go to the 4th row of Pascal's triangle right here. So my coefficients are going to go 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Make sense? Cool. So if we wanted to expand something all the way out, here's what we're going to do. The first thing we're going to do is we're going to go in and put in our coefficients. So right now we have a plus b to the 5th. So that means I need the 5th line. So 1, 5, 10, 10, 5, 1. So I'm going to put those in. 1, 5, 10, 10, 5, 1. Now we're going to go through and put in all of our terms with the powers on them. So if you noticed, I started with a to the a squared, when my power was squared, and then a to the 1st, and then a to the 0. When it was cubed, I had a cubed, a squared, a to the 0. With to the 4th, a to the 4th, a to the 3rd, a squared, a to the 0. So here's what's going to happen when we expand. That first term is going to go through, and it's going to start with that power. So I'm going to have a to the 5th. Then the next one is going to be 1 less, a to the 4th. Then the next one is going to be 1 less, a cubed. Then 1 less, a squared. Then 1 less, a. Then 1 less, nothing. Okay? Now, let's take a look at what's happening with b. Now, we are also going from 3 to 0, but we're starting at the other end, right? Or going from 4 to 0, but starting at the other end. So a, I started at the beginning and counted down. For b, I'm going to start at the end and count down. So b to the 5th, because my power is 5, b to the 4th, b cubed, b squared, b, no b. So this is just a way to expand a binomial without having to multiply it out the whole way. Because multiplying something out 5 times would be a pain in the tushy, and then you're looking for like terms to combine, and it's just not fun to do. So if you can use Pascal's triangle, that's a lot easier. So things you should notice about binomial expansion. So the number of terms in the expansion is always one more than the power. Let's double check this. Well, in the 0th row, we had 1 term. In the first row, we had 2 terms. In the second row, we had 3 terms. Power 3, 4 terms. Power 4, 5 terms. Power 5, 6 terms. So it's always one more. The coefficient of the first and last term is always 1 before we simplify. What I mean is before we simplify, a or b could be a number. So when we start squaring that or cubing it, throwing some powers on there, they're going to end up being something other than 1 probably. Also, the coefficient of the second term and the second to last term, so these 2 terms right after those 1s, those are always going to match your power before you simplify. Another thing to notice is that the sum of the powers on these 2 guys, so like a cubed b to the first, sum is 4. A squared b squared, add 2 and 2, you get 4. 1 plus 3 is 4. So if you add the powers up, the sum of the exponents in each term is going to be the power on the binomial. Okay, so let's try this guy. We want to expand the binomial using Pascal's triangle and then simplify. So the first thing I want to do is identify which line am I supposed to be on. So since I have x plus 2 to the 5th, I'm going to have to go to the 5th line of Pascal's triangle. So remember, oopsies, 5th line is right here. 1, 5, 10, 10, 5, 1. So here we go. Oopsies, here we go. So we have 1, and then I have 5, 10, 10, 5, 1. Cool. So I space it all out so that way I can put in all of my other pieces to those terms, and then I can go through and simplify. So what I'm going to do first is I'm going to go through and take my x, and remember he's going to start from here with x to the power that's on the binomial, and then I go down 1 each guy for the power. So I'm going to start with x to the 5th because that's what's on my binomial. My next term will have x to the 4th. My next term will have x to the 3rd. My next term will have x to the 2nd. My next term will have x to the 1st. My last term will have x to the 0 power, or no x there at all. Now I'm going to go through and take my second guy, that 2, and he's going to start from down here. 2 to the 5th, 2 to the 4th, 2 cubed, 2 squared, 2 nothing. Right? So we're going to go backwards. So times 2 to the 5th times 2 to the 4th times 2 cubed times 2 squared times 2 to the 1st, and then I would take that times 2 to the 0 power, which is just 1, which doesn't matter at all. So now all we have to do is just go through and simplify. 1 times x to the 5th is just x to the 5th. Plus 2 to the 1st is 2. 2 times 5 is 10. And then I had an x to the 4th. Plus x squared is 4 times 10 is 40. And then that x was cubed. 2 cubed is 8 times 10 is 80. And that x was cubed. Or squared, I'm sorry. 2 to the 4th is 16. Times 5 is 80. You have that x plus. And then we'll take 2 to the 5th. 2 to the 5th is 32. Beautiful. So that's our expansion. Now, the next one is going to be almost even easier, except there's a little part you need to be careful of. This time I'm having x minus y here, right? Remember that that second term is negative y. I'm really taking x plus negative y, right? So think of that b term as negative y. Make sure you put parentheses around it so you make sure that when you square it, he turns out positive. So here we go. Since this guy is cubed, I'm going to have to go to the third line of Pascal's triangle right here. So 1, 3, 3, 1. 1, 3, 3, 1. Good deal. Now we're going to take our first term, start from the beginning, start with our power, and then go down 1. So I'll have x cubed. Then down 1, x squared. Then down 1, x to the 1st. Then down 1, x to the 0. Now we'll go through with y. So now I'm going to start with that negative y down at the other end, and he has the power that's on the binomial of 3. Then this next time I'll have the opposite of y, and he'll be squared. And then we'll have the opposite of y, and he'll be to the 1st. And then I'll have the opposite of y to the 0 power, or just not have it in there. So now I'm going to go through and simplify. So 1 times x cubed is just x cubed plus. I have negative y times all of this. So since I'm taking that times a negative number, that actually means that this whole thing is negative. So I'm going to put a minus sign there instead. So we have 3x squared y. Okay. Now over here, I have the opposite of y squared. So when I have a negative number and I square it, a negative times a negative is a positive. So this term right here is also positive. And we have a 3, and we had an x, and our y has a power of 2 on it. Plus. Oh, oops, I won't have a plus here because I'll have the opposite of y cubed. And when I cube a negative number, that's going to come out negative. So 1 times negative y cubed is just negative y cubed. Okay. So we want to write the first 3 terms of the binomial expansion and then simplify it. So the name of the game here, guys, is parentheses. All right, cool. So we want to write the first 3 terms, just the first 3. That's it. We don't have to do the entire thing. So first thing we're going to look at is what the power is on the outside, and that power is 6. So that means we need to look at the 6th line of Pascal's triangle. So 6th line is the one that starts with the 6. That's right here. 1, 6, 15, 20, 15, 6, 1. However, we only need the first 3 terms, so I'm just going to use 1, 6, 15. And then I'm going to put some dots afterwards. So we have 1, 6, 15, and then that will continue. So the first thing we want to do is go through and take our first term. Our first term is 3x squared. So we want to put parentheses around 3x squared. Come on. And then we'll put our first term to the appropriate power. So our first term should always go to the power that we have on our binomial. So that would be to the 6th. Then in the next one, we would have our first term to the 5th. Then our first term to the 4th. Now, if we were expanding the entire thing, we would start way down at the other end with negative 5y and take it to the 6th, and then to the 5th, and then to the 4th. Well, let's think about it kind of in reverse right now. So we know from experience that this first term would be negative 5y to the 0, or nothing there. Our next term is going to have negative 5y to the first power. The term after that will have negative 5y to the second power, and then so on and so forth, right? Okay, so now we're going to go through and simplify each of these. I have it in my notes down here so I can look at it. I would get out a calculator because I wouldn't be able to do this in my head either, but I'm definitely going to show you how this works. So remember that 6, when I have two things that are being multiplied, it's going to go, that exponent is going to go to both of those. So I'm going to have 1 times 3 to the 6th times, and then I have x squared to the 6th. When I have a power to a power, I multiply. Or if you think about it, I have x squared 6 times, which means that I would have x to the 12th. Now I have 6 times. Remember, the exponent is going to go to both of these. So we'll have 3 to the 5th times x to the 10th, because I have to multiply my powers, times negative 5, since that's to the first power, times y. I promise I'm going to clean it up here in a minute. Just putting everything out so we can everybody can see what I'm putting into my calculator. On the next one, so we still have that 15 times. That exponent of 4 gets distributed, so I have 3 to the 4th. Multiply my exponents, we have x to the 8th. And then negative 5y squared. So negative 5 squared is positive 25. Y squared is y squared. And that will continue. So now I'm just going to put things into my calculator that I can. 1 times 3 to the 6th is just 3 to the 6th. So if I put 3 to the 6th into my calculator, I'm going to end up with 729 x to the 12th plus, and then I'll take 6 times 3 to the 5th times negative 5. So I'm going to multiply this, this, this all together. And we'll end up with negative 7,290. And then we had x to the 10th, y, plus, and then I'll take 15 times 3 to the 4th times 25. So when I multiply all of that out, that's going to give me 30,375. Then we'll have x to the 8th power, y squared. So a lot of these guys, the numbers can get real big real fast, but don't worry, you'll have your calculator there to help you. And if you don't have your calculator, I don't expect you to be taking 3 to the 5th times 6 in your head. Just leave it like that. Okay, So for the following, A, tell how many terms will be in the expansion. B, find the first two terms. And C, find the last two terms. So first of all, how many terms will be in this expansion? So since I have 2x plus 3y to the 10th, remember how many terms are in the expansion is always based on what that power is. It's one more than the power. So since I have to the 10th, that means that I will have 11 terms. Now we want to find the first two terms. So we know that on every line of Pascal's triangle, every row starts with 1. And then the next number in is always going to be the row number, or really the power on your binomial. So my next coefficient will be 10. Now we're going to go through and solve the same way that we did a moment ago when we just kind of distribute things out. So I'm going to have, my first term is 2x. So I start with that power on my binomial, 10. And then in my next term, 2x, and subtract 1 from my power, and that would be the 9th. Next, I would go through and take 3y, 10th, 9th, 8th, all the way down. That would mean that I would have 3y to the 0 power, so it wouldn't be here, and then 3y to the first right here. Remember, these two guys have to add up to my power right there. Now I'll just go through and simplify. So I have to take both of those guys to the 10th power. So 2 to the 10th is going to give me 1024. And then I have x to the 10th plus. And then I have to take 3 times 2 to the 9th times, I'm sorry, oh, I did say that. 10 times 2 to the 9th times 3. So 10 times 2 to the 9th times 3 is going to give me 15,360. And then we had x to the 9th, and then we had a y. So there's my first two terms. Now let's find our last two terms. So we know with the last two terms, the second to last term is going to be the power on your binomial, so that's 10. And the coefficient on the last guy is always going to be 1, kind of the reverse of what just happened. Now we would have taken 3y, and he would have been to the 10th power all the way down here. And then we would have subtracted 1 to get the second to last power, 3y to the 9th. Now when we would have taken 2x, we would have gone to the, earlier we did to the 10th, to the 9th, to the 8th, blah, 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 until at the end we would have 2x to the 0. Then over here we'll have 2x to the first, or just 2x. So now we'll go through and simplify. So I have to take 10 times 2 times 3 to the 9th. 10 times 2 times 3 to the 9th is 393,660. Ooh. X was to the first power. Y was to the 9th power. Plus. And then we have 1 times 3 to the 10th. 3 to the 10th is 59,049. Excuse me. And then I have y to the 10th. Good deal. Okay, so last one. Now we're going to looks a little bit gross. We're going to have x to the 1/2 plus 1 to the 30th. It's actually kind of nice since any 1 to any power is just 1, so it really won't be too gross. So how many terms will be in this expansion? Take my power and add 1 to it. So 30 plus 1 is 31. Then we need our first two terms. So my coefficients are 1. And then my second term's coefficient, I'm going to move that up a little bit, is going to be the power on my binomial. So that was 30. My last two terms, the second from last term, is going to have the power of my binomial. And my last term always starts with a 1. Now let's talk about that first term. So that first term is going to start to the power of the binomial, and then we subtract 1. So we'll have x to the 1/2 to the 30th, and then x to the 1/2 to the 29th, and then to the 28th, 27th, 26th, blah, 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 until we get to the end, right? And then we'll have x to the 1/2 to the first, and then x to the 1/2 to the 0, meaning it's not there at all. Now let's go through with the 1. So in this first term, right here, I would take 1 to the 0th power, so nothing there. Then over here, I'll have 1 to the first. Now, if we start going on from the other end, oops, I shouldn't have put dots right there, my bad. Over here, I would have 1 to the 30th in the very last term, right? So I'm going to multiply that by 1 to the 30th. And then my next term is 1 less than that, so 1 to the 29th. Beautiful. So now let's go through and simplify each one. So for the first two terms, I'm taking 1 times x to the 1/2 to the 30th. So I don't have to worry about that 1 times at all, right? X to the 1/2 to the 30th. Remember, when I take a power to a power, I multiply. So it's 1/2 of 30, 15. So we have x to the 15th. Plus. Now, with just plain old numbers, I have 30 times 1 to the first. So 30 times 1 is just 30. And then I have x to the 1/2 to the 29th power. If I multiply those, that's just going to be 29 halves. If you want to put that as a decimal, you could, but usually we go ahead and write exponents as fractions, because then if we want to turn it into a root or something like that, we have a better way of doing that. Okay, and that would continue. Okay, and then our last two terms, so we had some stuff before that. Okay, so I'm going to have to take 30 times 1 to the 29th. So 1 to the 29th is just 1 times 30 is 30. And then I have x to the 1/2 to the first is just x to the 1/2 plus. And then I have 1 times 1 to the 30th is just 1. All right, so next time we're together, I will show you how to do binomial expansion without Pascal's triangle. And we are going to love on our calculator, so make sure you have that with you, okay? I love and miss you. Bye.